How is it that fusion and fission of atomic nuclei give rise to a net output of energy? It's a similar concept to how we get energy from chemical reactions. If I take hydrogen and oxygen and combust them to turn them into water, the atoms on average are much closer in the form of water than they were when they were just pure elemental hydrogen and oxygen. And as a result of that, that net energy difference between them being further apart and closer is what we get out in terms of heat. The same thing occurs when you combust organic material and turn that into carbon dioxide and water. The average distance between the atoms is much lower in carbon dioxide and water than you had for the organic matter and the oxygen originally. A way to think about it is this. If I had just the hydrogen atom and I had the electron removed off to infinity, and then I had the proton and I took them together. As the electron is approaching the proton in order to make hydrogen, I could use that attractive force between the positive and negative there to do work. I could turn a lever, turn a wheel, or whatever. That energy difference is what we get when we actually form hydrogen from a plasma, or basically when we take the electron and bring it down. And that's because the electron is now a lot closer to the proton than it was when it was off at infinity. The same applies when I'm doing chemical combustion or something like that. The electrons are going to be much closer to the nuclei, and so you get net energy out. And that's what happens effectively when you do fusion. I take two deuterium nuclei and bring them together. The strong nuclear force pulls them together really, really tight. And the energy difference between being off at infinity and next to each other is what's given off as heat. Basically, it's the same amount of energy you would need to put into the nucleus to strip out the deuteron and separate the two deuterons from a helium nuclei. Now, fission, it's probably more analogous to the actual chemical situation. When I have a large nuclei like uranium-235, then the nuclei are very loosely bound. The strong nuclear force is kind of like the van der Waals force. It only it goes to nearest neighbors, so that one nucleon, a proton, will only see those that are touching it. It doesn't really have the strong nuclear force to the next ones over. And so as a result, those next ones over are being repelled by the protons. The protons are pushing all of them. And the strong nuclear force is able to overcome that in these massive nuclei, but it does push them further apart. So when I split those nuclei apart and make a smaller nuclei, the nucleons on average are going to be a lot closer together. And so that energy difference between them being far and close is what's given off in fission. So thanks for that question. I appreciate it. You have a good day. Bye.